during the whole webinar to make our webinar successfully. So during the whole live sharing, may I have a request firstly? First, please mute your microphone. And second, for your questions and comments, we will be appreciate if you can write it in the chat room and we can interact there. So here's the agenda for your reference. Today's agenda includes mainly 4 parts. The first part will be presented by our Business Development Manager, Mr. Ruslan. Its subject is edge computing market trends and industry directions. And the second part will be presented by our Customer Solution Manager, Mr. Gary. Its subject is applications and case scenarios. And the third part will be presented by our product manager, Mr. Grace Jung. Its subject is BRAV Edge Solution Offerings. And for the last part will be presented by Ruthly again. It's an honor for GEC. Its subject is Inter White Paper based on GEC Tech MEC equipment. So here's the whole agenda for your reference. And I think it's time for us to welcome Mr. Ruslan to give his sharing. And hello, Ruslan, are you there?
You hear me well?
Yeah.
Okay,
Hi, Ruslan.
Hey, thanks. Yeah.
Wait a moment, please.
Sure.
I'll find your name. Okay, so for now you can run the PowerPoint, right, Ruslan?
Yes, I can.
Okay. Actually, Ruslan is our business development manager, and he is located in Taiwan. So it's time for you, Ruslan.
Hello, Kerry. Thank you for setting everything up and starting the conversation. I hope everyone can hear me well. Please excuse me if there are any construction sounds. There's a little repair going on in the neighboring office. So if any questions, please, say through the chat. First of all, I'd like to briefly introduce myself. My name is Ruslan. Feel free to call me Russ. I'm focusing on the business development side and interested in business aspects of questions why, what, and how. So why do we do what we do? Why do we need embedded solutions, and why edge? What value, solution, services we can provide, and what goals we can achieve together with our partners? And how can we build the best solutions? How can we approach new positions, directions, and how can we stay in leading positions? So first of all, Merry belated Christmas and Happy New Year to everyone. I'm from Russia originally, so actually today, January 14th, is the Russian New Year. So Happy New Year, everyone. And in a few weeks, we'll have New Year in China. So, as you can see, we are having holidays for quite a while. Anyways, let's move to the a bit complicated but exciting topic. And please apologize if I'm, skipping quite fast through. I'll be happy, to chat with you all separately, one-to-one, personally. I can deliver, more information in details. So you will receive this presentation afterwards. Feel free to, ask any questions, and also feel free to request that, I can call you up with your sales and provide more detailed description on each slide. Anyways, you probably know edge computing from telecom, often referred to as mobile edge computing, MAC, or multi-access edge computing. Basically, it provides execution resources, computational storage for applications with networking close to the end users, typically within the boundary of operators' networks. You can definitely see the value in this, but frankly speaking, it's been a long way and number of technological waves passed that we now can operate in a more distributed and effective world. Historically, there are a number of exciting developments happening, like introduction the content delivery network (CDN). I'm sure many of us, still remember that time, beginning of the internet. Japanese and Akamai were quite strong. This was mostly to serve media content to internet users with optimized availability and performance, followed by ubiquitous computing with cyber foraging, which is a computing technique where small mobile devices offload resources intensive work to stronger nearby surrogate computers in order to preserve energy and achieve better performance. I'm sure people remember P2P communication. I'm sure people remember P2P communication, whether for video, media, payment, and security communication. Interactions between swarm of peers. So, P2P was quite popular and actually still growing pretty strong in Africa and Southeast Asia when it comes to, payment or transactional systems. Cloud computing, something we're still using and which is essential for our daily life. Most of current services, whether governmental, industrial, or personal, rely on interaction between our mobile devices and cloud processing and storage. In addition to cloudlets brought faster connectivity and more interactions, and cloudlets would execute in the intermediary functions. Growth of IoT led to the need of not only fast scalability, but also improved latency and requirement to minimizing energy. We're dealing with mobile applications with limited access to power telecom connections. And here we go, the H. A unique cross section between almost zero latency and outstanding computing capacity. Just by realizing how far we came from spending hours downloading music from the internet and playing real-time online games, and now renting a car and accessing everything just through your cell phones. We've heard about Industry 4.0 for quite a while. Taiwan, Germany, Asia. It was booming for almost 10 years, 8 at least. But I believe that these days we can literally feel the impact of it in our daily life. We update our cars remotely. Most of government and private services are done through sub-networks, providing full real-time experience. We enter hotel rooms, past security lines, without even interacting with the staff. And in the back end, network sensors, controllers, processing units, and monitoring systems are running almost 24/7. The amount of data that has been processed, filtered, analyzed, and reacted upon is enormous, which brings us to the need of the real intelligent approach. These days, we rely not only on the speed of connection, but the value of the data that is being transferred and speed of the analysis of that data. There is where the true edge comes to processing capacity outside of the cloud, close to the end user applications. At the same time, every technology, comes with a good and bad. On this slide, there are a few examples of basically projects to be done, with the cloud and edge. My experience is mostly related to smart city and transportation. So I'll use city bus project as an example. I'm sure we realize that having processing unit on the bus is quite important. Before, we normally just gather all the data from various sensors and wait for to download to a central terminal just for storing. With a number of projects in Russia, Turkey, Germany, Southeast Asia, where basically we equipped thousands of buses and provided this kind of full solution to the government or local shipping companies. But mostly it's just gathering for particular insurance, or if police comes for to resolve a few issues, or let's say for after case analysis. With 4G, we're able to gather even video data for quick upload to the police or emergency response monitoring centers. Like in Europe, there are communication networks between police, hospitals, and logistic companies. With only one red button, you can ensure that all the data just streams to your police or hospital. And in that case, they understand the data. They understand whether bus or car was upside down, what kind of speed, what collision, so they can prepare better in advance and respond faster. But this was still just data collection. Modern design of edge computing box PC allow us not only collect data, but process and react within the subnetwork. For example, playing ads or media depending on the weather or who is sitting in the bus. With 5G, bus itself is not a closed system anymore and can directly connect to any city infrastructure security through encrypted routes and internal security protection, for example, using Intel virtualization. What's important is that there is no need to have all the data on the server on the edge device, but rather to be able to access necessary data at almost zero latency speed, process this data, and share with other business on the road without going through the server. This kind of projects are happening in Asia quite often, and recently we see this is booming with Panda Express, Uber, Gogoro, and number of, let's say, smart scooters and smart cars. Same as with the Tesla, all the data has to be analyzed right on the vehicle, not purely, for the, let's say, data visualization, but also for the commercial use. So frankly speaking, it's already quite easy to understand the financial benefits from such, edge solutions. At the same time, drawbacks we can see so far: the need for standardization. There is something more political than we hope for. But when it comes to data processing and collection, global standards are needed. Security, deployment, and maintenance is something that has to be thought of much in advance. All these aspects are critical for success project implementation. Both software and hardware have to be selected only after scalability, management, and security issues are outlined. Please remember that. Which leads to actual investment required. From my experience, edge projects cannot be divided into simply hardware and software. It is a new way of thinking about data processing and long-term vision. Only when application and project cannot be done any other way, then edge computing can be used. Otherwise, in many cases, it can be just a waste of money and time, like buying a powerful computer and using it only, for watching movies. As you can see, the business model is the key in any current project. And I would say the question, why do you need the edge, is the person to ask your client. Okay, thinking about what values this can lead to and what goals to be achieved. I put up a few slides just to show you some directions which most telecom and investment advisory firms are referring to when talking about the use of edge computing. As you can see, according to McKinsey and other public data, we see the majority of investments will be in energy utilization, industrial, and transportation. Frankly speaking, quite understandable. Most of the cases are funded by government or funded by large private companies where you can clearly see the benefit, whether it's transportation logistics, like right now because of the COVID, companies have to be more efficient, have to make sure there are less people at their factories during transportation hubs. So data analysis basically gets funded. Energy utilities, it's always more and more people, whether it's Turkey or Russia or Indonesia or Philippines or Taiwan, solar energy, wind energy, and even just basic energy transmission and utilities are always funded, as this is as basically those government companies, the only way for them to increase revenue is to improve efficiency by minimizing latency and to provide better services, for which edge is definitely a good use. We can also see that talking about the hardware, we first of all the hardware company. Many of our partners are software or SI or distribution, and we can see that talking about our client piece, beside using the software and providing particular service, the hardware is still taking quite a big toll in terms of investment. So travel, transportation, logistics, cross-vertical, and healthcare infrastructure are still the largest buyers in terms of SI and end users. It's understandable. Video analytics, data monitoring, AIoT for the factory automation, advanced analytics for, let's say, logistics, location services for government buses, optimize local content as well for any media company. This is where the money are at, and follow the money. If there is funding, if there is a business case, then they have to buy the hardware. And knowing that for all that video monitoring and video analytics, it requires quite substantial, GPU and CPU hash and power. So in this case, edge is must. At the same time, you realize that both of these projects, have hardware and software needs. So money will be allocated, in various ways. I'd like to, briefly show you guys just an example. We're talking about mostly infrastructure or government, bus, logistic, that sort of, smart IoT projects. On the other hand, many of the projects are cash cows in Asia, like, for example, this agricultural one. Talent, shrimp, Taiwan, fish, or bamboo, or a number of other fruits. I'm not sure about Turkey, but let's say Holland with their flowers, as well as the orchids in Taiwan. Russia, we have quite strong agriculture as well. All these projects are being done this couple of years with faster and faster speed in terms of not just executing but investment as well. Why? Because these are traditional industries. They are so far behind the telecom, mobile, and transportation that right now the new investors or second generation owners or simply system integration companies see the real value in improving that. For example, there's the project case in Taiwan with fisheries. Before, there's so much waste, whether it's from the fish or when you feed the fish, as well as there's not much clarity on the safety, not much clarity on the impact to the soil. And what's happening is whether Taiwan or China or another country, normally your products are being exported. Whether we export to Arabic countries where halal is needed, right, or even Indonesia, whether we export to some UK and European countries where traceability is a must to make sure there's not like a DNA from different animals inside your fish, right? So, and banks as well, they're very careful. They want to see the data. They want to see the data to provide you a loan. So fisheries are pretty easy cases for us, and I believe that for you as well. I suggest to take a look more in this market as it's a very clean and clear business use. With controllers on each, for example, fishery site, we can gather the data, process, and mitigate a lot of the waste issues, as well as to basically adjust the feeding systems remotely. What's happening is many of those fisheries are quite far. So in this case, what we do is we collect the data, analyze in different regions. So the monitoring center somewhere in Taipei or in Moscow or in London analyze all the data and basically adjust according to particular requirement. For example, this year temperature is changing, so we can adjust the feeding system. We can adjust maybe temperature of the warming or cooling systems. We can even see the result, the quality of the fish, and trace it back to what food they had, what temperature they had, how much sunshine they had. So in that case, we can optimize and make sure that the quality of the fish that we provide to end user is, which goes back to the better service to our clients. And just last few slides. Once again, gentlemen, we don't have much time on me today. My part is a bit boring, so I ask you, please, whenever you have any questions, feel free to send a message or just call you, ask your sales, and I'll be happy to jump on the conference call with you to share more financial and data that you're able, to catch more opportunities in your market. And just an example about the U. We know the concepts, whether it's IUV, IoT, AIoT, Trust IoT, all of them. But we have to realize that no business happening without the correct framework, private, government, and open source. And no projects are happening without the platform, like NVIDIA AI platform, GHC, EdgeTech, or GHC partnership ecosystem. Only then we can provide the solution. So understand that in many cases you realize that market is pretty tough, but I ask you, please, open your news, open some government websites, and try to gather more information regarding the frameworks and cross-border corridors that are happening in your region. In this case, believe me, you will see there are so many opportunities that we also can help you with. Because at the moment, we are partnering with a number of companies, a number of institutions, as well as the building a system with Intel and other similar partners like NVIDIA, which allow us to enter projects and provide, let's say, not turnkey, but close to turnkey solution for your end users. And for you, you just have to basically show your end users that those are funded. Like you can see in Europe, there are a number of investments provided for transportation ecosystem, for optimizing the logistics, optimizing the traceability in the food and shipping. And back to this is basically actually mostly for distributors. You can see that in the intelligent transportation market, which I believe that GHC is one of the leading companies, and from our experience, whether it's Hector who is here, or Gary, or Sherry, or myself, we've done plenty of projects with transport. A majority of funding spent for services, which is good for you, gentlemen. Services are basically the cash cow for you. On the other hand, we see that 21% is still for the hardware. The majority of our clients are distributing a sort of mix of hardware and the software. So that's why I suggest to talk to your sales more and to get more feedback in regards to what software you can use, what hardware and software package we can provide to you, or you can actually provide to your end users. Okay, guys, at the moment I'm finishing up with my part, and I'd like to introduce our PM, who will be speaking further in regards to applications and case scenarios. Once again, send me any questions and feel free to ask yourselves as I get on board with the conference call and explain you more in details. Thank you. Gary?
Hi. Hi, thank you for your sharing, Rosaline. I think it's time for Gary. Hello, let us welcome Gary.
Hello everyone, I'm Gary. Nice to meet you again. Last time I have introduced some solutions, and today I'm here to introduce our BRAV series applications. When talking about the transport station projects, from our experience, they are all consistent of three layers. They are cloud layer, marginal layer, and terminal layer. Previously, most of our solutions were used in marginal layer, where high capacity for computation and distributed system is necessary. BRAV series is perfect for MEC type of projects. At the same time, recently, we also engage more in terminal layer, where our in-vehicle embedded box computer has great advantage gathering all the data from the vehicle and analyze it without sending to marginal layer or cloud layer. You can see from the picture, our BRAV series products can be also used for cloud, or it can be also used in vehicle box computer. We have quite a strong experience working on both private and government projects. Most of them are partial. For example, section of the expressway or major roads in the large city. These projects are most focused on traffic surveillance and government services, as well as close to real-time city processing. Here is an example, CVIC projects. It's very common globally and already a very standard solution. Because of increase in network speed as well as the low cost of cameras, more and more cities are doing the massive projects. Okay, let me introduce this picture. There's a data acquisition system comprised of the cameras and detection radars collect the road vehicle information in real time. This information includes the vehicle location, speed, distance, road traffic lights, and pedestrian information. The edge computer platform BRAV 7302 analyzes through a dedicated algorithm and then transmit the analyzed data to the cloud platform. At the same time, the analyzed data is fed back to the RSU device. After the RSU device transmits the received information to the onboard unit OBU, it can make judgments on complex road conditions and provide strong support for the driver or the automatic driving system. The driving system can obtain more road domestic information, such as vehicles or pedestrian information. Through the vehicle road system, it can reduce cost, such as the sensors, and greatly reduce the burden of the data processing. Task planning to achieve efficient transmission and can drive automatically. I don't want to bother you with many projects that we have done, but I would like to outline some of them which I'm very proud of it. Frankly speaking, I believe most of these projects can be used in any country, especially when it comes to expressway, cities, or logistics infrastructure. For example, the warehouse and logistics cases are normally done by international companies who want to optimize their internal resources. It can minimize cost of the operations and have 100% traceability for their goods. This is a driverless disinfection built by JHC and Harbin Institute of Technology for a large domestic bus group. Integrates artificial intelligence, machine vision, image recognition, precise positioning, and other artificial intelligence technologies. It can independently identify the environment and plan the route and automatic cleaning. Give the full play to the role of the information network platforms such as Internet of Things, cloud computing, big data, and so on. To achieve full working conditions, refined and efficient cleaning operations, so that the pain points of the sanitation industry can be overcome. This project used our BRAV 7302 equipped with the Intel processor and GTX 1060 GPU. And it's an application system developed by our partner through the front-end GNSS measurement unit, LiDAR, millimeter wave LiDAR, and industrial cameras, and also alarm real-time ranging, automatic detection and sensing of surrounding the environment. Upload the image and the data to the MEC, its computer system, to processing and upload the processing result to the cloud platform to assist the remote controller to make judgments. The unmanned disinfection sweeper can realize the fully automatic unmanned driving, automatic steering, turning, and up and down. Warnings are issued in real time and work around the clock. And through the web cloud platform, one-click recall can be realized, and multiple unmanned disinfection sweepers vehicles can be remotely controlled at the same time. And the multiple systems are integrated with high efficiency and intelligence. This is another example of the installation site. We constantly driving to customer sites together with them to help with the development and setup. What is interesting is that our customers can see benefits of these systems right away and soon starting to copy the same solution for a large-scale development. In China, we have fast growth of food delivery, car rental, or the taxi platforms like the Didi Express. Some of the projects are done to improve the safety and the speed of these platforms. We have received many inquiries from companies that work on upgrades of the old stations. It is very expensive to completely upgrade the train station or the airport. That's why our technology companies focused on upgrades of their box computer and the software. Our edge computing computers are used to expand the capacity of the older machines and systems. With the increasing number of the people and trains, high-performance computers are necessary. Here are some pictures at our Beijing railway station. This is our BRAV 7302, used for scanning and checking your luggage. This solution is used very widely as the train station or the airport or subway station. This is a quite interesting project, and solutions becomes more and more popular. Before, only professional athletes go to lab to analyze their mechanical data and increase performance. Now, more and more fitness equipment manufacturers adopt the same approach and embedded the analysis with 3D camera solutions for their products. Okay, and that's all for my introduction of our solutions. Next, our product manager, Grace, will introduce our product features. She is our product manager and has very good experience of our products. Okay, let's welcome Grace.
Hello everyone, I'm Grace. I'm the product manager. It's my pleasure to introduce our new product series to you, BRAV series. BRAV series we also define it as MEC system. It means a much edge computing system. It have rich I/O collection and can support different AI computing. Here's the comparison table of BRAV series. You can see that we have 5 solutions. They powered by different AI, different CPU, and have support different AI accelerator card, and have different AI hash rate. Here's we have 5 solutions. Here's the keyword of Bravo Zero's product feature. It basically comes down to aspects. The first one is that the AIoT multiple architecture. It means we use Intel x86 CPU as our infrastructure and plus AI architecture to support higher graphics and data processing requirement. The second aspect is the modularization, all-in-one design, and efficient hedge dissipation. Except you can see in the picture on right, except the CPU air duct, we design an independent GPU air duct for GPU cooling. Here's the detail of AIoT architecture. As the CPU as the main processors at learning covered the equipment access protocol transition and data analysis. Also cover the communication management and data exchange and storage and remote management and maintenance. For AI architecture, it's mainly covered rich oscillate and decode and deep learning. Here's our AI architecture. Here's the 5 solutions of Bravo Zeros. The first solution is Bravo 7201. It's powered by Skylake and Capelake U0s. Can support 1 M.2 accelerator module, which have 8 TOPS hash rate. Also, this solution have 2 4-key display ports, HDMI and DP. Can support wide power input from 10 to 30 wattage. This solution is widely used in artificial intelligence, machine vision, and robot industry. Here's an architecture diagram applied to MEC system. Okay, can you hear me? Okay. Okay, let's continue. Here's an architecture diagram applied to B2X. You can see in the picture that Bravo 7201 can only connect 1 radar, 1 camera, and single lampos because it only have 8 AI hash rate. It can only support 1 radar and cameras information analysis. And besides the application in V2X, Bravo 7201 also can apply in machine vision, HEV, unmanned drive, and AI industry. This is the second solution, BRAV 73002. This solution is powered by Skylake and Kaby Lake S0s, can support 1MXM 3.1 GPU, have 16 TOPS AI hash rate. This solution can support full range of NVIDIA GeForce GTX and AMD RX GPU. This GPU power consumption should be below 120 watts. And BRAV 73202 have 6 4K display ports. 3 of them from CPU and the others from GPU to provide much or dual HD display at the same time. And this solution, because this solution uses one Intel 2189 chipset. So it can support Intel Vapor technology and also can support TPM2 encrypt. For the storage of BRAV 73302, it have one M.2 PK, can support PCIe 1 and SATA 3 and USB single. Have with the same slot. Also have one mSATA and 2 SATA 3 support the data disk RAID 01. This solution is widely used in video security, machine vision, and AI industry, and etc. Here's the application of BRAV 73002. It can use in AI edge computing, HCS, and HV, machine vision, and intelligent safeguard systems. Here's the application of BRAV 73002 in HV industry. As a motion controller and communication management processor, BRAV 73002 is responsible for motion control and wireless communication, task management, and data storage and forwarding functions. This is the third solution, is BRAV 7501. It's powered by Coffee Lake Refresh. It can support 2 PCIe accelerator card and 1 M.2 accelerator module. Up to 264 hash rate. This solution is this solution's power supply is AC in and IPX AC in. So it's in the right on the right we list some GPU card and FPGA card for your reference. The fourth solution is BRAV 7520 and 7521. Both of them powered by Coffee Lake Refresh series. For BRAV 7520, it have 2 PCIe expansion slots. Can support 2 PCIe accelerator card. Also can support one optical interface port card. Have up to 128 TOPS hash rate. For BRAV 7521, it have 4 PCIe expansion slots, can support 2 PCIe accelerator card, and have 1 M.2 AI accelerator module. This solution can support up to 264 TOPS hash rate. Both of them can support 4G and 5G module. For Bravo 720 and 7521, both of them have unique power supply design. You can see that both of them can support one power card. This power card can support 1,000 DC in, can support 350 watts GPU card for load power supply needs. This is our power card. And the other unique power supply design is that for PCIe expansion slot for PCIe 16 slot, we design an independent auxiliary power supply. This slot can support maximum 75 watts GPU card. 75 watts GPU card's power supply needs. So this is our solution. The solution 4. This is some key features for solution 4. You can read it offline. Here's the application for Bravo 7501 and Bravo 7520 and 7521. They can used in intelligent driver and traffic side MEC and HEV and intelligent safeguard systems, machine vision and AI medical. I list some subdivision normal. You can read them offline. Here's Bravo Zero's architecture diagram applied to V2X. Just now I have introduced Bravo 7201. The other 4 solutions also can apply in V2X. The difference of them is that the difference of them is that they have different AI hash rate. It means that for Bravo 7201 and 7302, they can only connect one radar, one camera, and one RSU devices. All other intelligent control tablet or traffic light controller. But for 7501 and 7520 and 7521, the 3 of them can connect 2 or 3 or 4 radar and camera and RSU devices because they have over 100 AI hash rate. It can deal more picture and data and video informations and to analyze them and feedback to RSU or upload to the server system. Here's a new solution. We plan to use Intel Common Lake and Rock Lake 2+1 MXM accelerator module. It also have 128 TOPS AI hash rate. This solution we cooperate with Intel. It will be considered as Intel MEC POC project. It can use in artificial intelligence, machine vision, and robots industry. Here's some AI, some GPU card I list, and some function card, and some relevant accelerate I list. Just for your reference, you can read them offline. Here's the competitive product analysis. We list 3 other brands to compare GHC's BRAV 720 and 7520 and 7521. You can see in the picture that BRAV 7520 and 7521 can support 3 LAN port and can support 5G module. Also, BRAV 750 can support auxiliary power supply for PCIe expansion slot. Also the expansion slot can support full H AI card adopt active H dissipation without air duct. Also can support half H and half length AI card adopts independent air duct for H dissipation. Here's all my sharing. Thank you.
Okay, thanks for great sharing for us. And as we know, DC Tech always keep a very good relationship with Intel, and there is a very good news to share to all of you, because one of the solution from DC Tech was filed into Intel white paper. So I think next Ruslan will give some introduction about the white paper from Intel. Hello, Ruslan, are you there?
Can you hear me?
Yes, I can hear you. Okay.
Okay,
It's your time.
Sure. Yeah, gentlemen, basically, you'll be receiving this paper through email. Hello? Okay. Kerry,
Okay
can you please turn off your voice?
Yes, I have. Let me try again. Wait a moment.
Okay,
could you please try, Ruslan? Just now I tap it.
Please turn off your microphone, okay?
Okay, please try.
I'm okay here. Gentlemen, anyways, Patrick, our marketing person, will be sending this white paper to you through email. So please, check it out. Basically, solutions depends on different countries are different, but platforms are the same. So what's happening is over here in Asia, we have close relationship with NVIDIA and Intel. And from time to time, our amazing PMs and engineers working close to adjust our hardware solution and basically develop some further products based on suggestions from Intel, and of course based on projects that we currently are working on. I'm not sure whether you've seen the structure before. It might be a bit boring and technical at this moment. So I'll be sending you through email, and you'll have more clarity when you read the whole paper. But basically, our guys on Intel technology and PMs working from time to time on providing our partners with sort of little, mini package in regards to particular industry. In this case, it's a vehicle to anything, V2X. We've done a number of projects, as both Kerry, Grace, and other PMs showed you before. And I think you've seen this as well. So as you can see, the roadside equipment being installed right at the spots where, like in Taiwan or the different countries, we have the systems to monitor the passing cars with those video cameras or, the sensors for the payment, remote automatic payments, or the road sensors, temperature for the weather, as well as the police and radars to monitor the traffic jams. These also could be sensors for the logistic, government, and systems that require certain data like Uber or Panda Express or all those, the automated car companies. They all need data about the road quality, about the traffic, or they need to find certain car, or they basically have to analyze what cars or the way they behave on the road. So solutions are pretty simple, I believe. In every country they are almost the same. On the other hand, what's happening right now, just share of data that is being monitored is way up. Fortunately, with 4G, 5G, and as you can see over here, we have installed Edge solution by DHC based on Intel. We can provide hardware package to upgrade, whether it's a private or government. I'm not going to go deeper into technology, but you can see the majority ones is just the computations, the little complex between the cloud edge and edge applications and the access network. I think the most interesting will be over here. Previously, like you can see over here, the vehicle, the bus, cameras, data center, MEC, cloud edge, equipment, let's say a truck or construction sites. Previously, what we've done with our partners, we normally work on each project separately, whether we have, camera video monitoring solution for road traffic, whether it's with Huawei or Everfocus or, the Bosch or any other providers, and those cameras using the OE, just simply sending data or monitoring the data, like, sending you a traffic ticket when you, speed. Vehicle and the bus or vehicle, collision or road obstruction or construction situations. These are also, normally separate projects that are done, by different system integration or infrastructure companies. At the moment, with ability to have MEC cloud edge spots between the cloud and the vehicles, we have more and more integrations. Whether you have solution on the bus, you have maybe some Tesla cars or other similar, cars driving with their own system. We have company that done video monitoring and they have their own data streaming, right? You have, some trucks and logistic companies that provide trucking solutions for the traceability and, the way driver behaves. Because normally, if you're a truck and driving eggs or chicken meat or milk, there are certain requirements, right? That the way the speed, the acceleration, the turn, the angle, the truck or the vehicle can actually do when driving. Right now, what we can do is we can collect all that data, put it on the MEC Cloud Edge, let's say box, as you've seen over here, and this apologies. And this is then open back to the data centers. But as before, it normally open to the government. Right now, it can be open to even private data collectors, whether it's marketing companies or the logistic companies or any IoT companies that require that data. So they can also install their software package, their software solution. And in this case, the data from the cameras, plus the vehicles, plus the trucks, plus the road sensors, are all basically being utilized by different softwares or even different companies within one MEC Cloud Edge box, which first provides very valuable feedback to private and government companies. Second, it provides a very good financial benefit, because this data can be sold for analysis. And three is it can actually integrate obsolete or old infrastructures, let's say system infrastructures. For example, I'm not sure about your country, but even in Taiwan or in Russia, sometimes we have different municipal governments or different infrastructure solution providers, or even like a police, medical, and data analytic companies. They have different solutions. So to keep them all in one framework, they cannot be. May have even different clouds. So before, you have to send only to one cloud. So only one basically end user. At the moment, we can analyze, send to different clouds, receive feedback from different clouds, and as well send different feedbacks and execution algorithms back to each section. So anyways, please read the white paper. Our guys on Intel PMs worked really hard to push it through, and this is just a beginning of our collaboration with them as well as NVIDIA. Please also feel free to communicate with Intel teams in your countries. You might be able to send you some projects on the way, or at least they're able to confirm that the solutions are fully Intel proof and based on Intel architecture. And for this, I'm very grateful to our PMs and engineers. Okay, guys, I think it's going to be all for today from my side. And this is the Q&A session. If any questions, please, right now it's time to share with me or with our PMs, through the messaging, or you can just, unmute your microphone.
Hi, Ruslan. Thank you for your sharing. And I think for the next part and the last part is if our partner have some more questions, you can ask it directly. You can open your microphone.
Gentlemen, we can hold you as well.
Hello. Is there anybody have some questions about today's webinar? And we can give some reply online and with Ruslan and with our product manager.
I'm sure there are a bunch of questions we will be afterwards. First of all, Harry, please turn off all the microphones. If anyone has a question,
but it's very noisy.
Hello, Carrie.
Yeah.
Thank you
Hi,
very much.
Pedro.
I have to leave. I have a meeting now. So I thank you very much for your presentation. Thank you to all of you.
Okay.
And keep in touch. Thank you very much.
Okay, thank you, Pedro. Thank you for our
Bye-bye.
team to join. Okay, thank you.
Bye-bye. Thank you.
Thank you.
Carrie?
Yes, Ruslan.
Please turn off the microphones.
Okay. I have turned on it.
Yes, but off.
Hello, Ruslan. I think this time our business partner is very positive. There are maybe 13 or 40 members to join. I think for some any questions, our business partner can contact our sales directly.
No worries, no worries. I'm sure
how about your idea?
everything is fine. What we can do is that Patrick will send all those details email to everyone.
Yeah, I saw the message. I saw the message in the screen. Marco, right? Yeah. We will send the PowerPoint if any partner have interested in. We will send them. No problem.
So what we can do as well is the Patrick will send information, including the separate marketing from the Intel. And in nearest 1-2 week, our sales will be in touch with you. And there's a chance that we may have a little conference call with you if you don't mind. And I will be as well on that conference call. So you might be able to chat more in regards to some data for the market.
Yeah, I think most of the our partner is busy for this beginning of the year. So I think it's time to end this webinar. And our team is very appreciate our partner to join today's webinar. And thank you so much for your time for listening. And we are looking forward to see you again, maybe in next month or in March. So thank you so much for all your guys. Okay. Okay, thank you so much for joining. See you next time. Bye bye.
就搞我的 PPT 是发出去给他们。
实在太吵了。先把这个拿出。